In this video, I'll show how to take this probed profile in the XZ plane from the top of a piston and make some modifications to it and then make a toolpath out of it. So first thing I want to notice is that if we do a top view, it kind of just looks like a straight line because that's looking straight down the XZ plane. So imagine that the piston was mounted on the table of the machine and we just told it to probe straight down in Z and then move over in X. That would be the XZ plane. Okay. So that's important. That'll come into play later for the video. So the first thing we can see here is, I've gone through this a couple times now, I can see that this first point is just barely over the center, okay, our origin there in the X direction. So I'm just going to take this point and move it over just a little bit, just so that it's not past the center, okay? And that's going to be really important later. Basically, we can't do what's called a surface of revolution if we have data crossing over the point where we revolve around. Okay, so just note that kind of thing is important. Okay, so then what I'm going to do is, so for this, the goal of this video is we're going to take this angle right here, this straight section, and we're going to change the angle of it. So maybe 1 or 2 degrees so we can change the shape of the piston. So I'm actually going to remove some of this. I'm just going to take all these points here that kind of make a straight line and just remove some of them. Okay, maybe like that. So we still kind of get that arc shape. And this is really mostly a straight line on the top, but the arc is what we want to keep in there. So then I'm going to come over here and say convert this curve to a spline. So this is what's called a polyline right now. It's just a series of points and lines connecting those points. We want to make that a spline. Otherwise, in this arc area here, we're going to kind of get these jagged lines when we go to actually machine this. So we're going to click and convert that to a spline. Now you can see it's one continuous sort of a curve, okay? So that looks good. And then the other thing we're going to do is say fix the curves. That just means lock them in place. So if I do that, I know that nothing's going to move this. If I start creating geometry around it, I know there's no way that this curve that we just selected is going to change, okay? So that's good. All right, so now I'm going to come over here to the graphics and just click, hit L on the keyboard for line. I could have also come over here and said create line. And then I'm going to click on this endpoint over here and just kind of draw a line up there. The exact location is not important right now, okay? And the first point that I clicked on, notice it was the same endpoint as the curve, as the spline that we just created. So that means those are locked together. Those are now considered coincident. So this is now considered one long curve. Okay, so that's great. So now I'll hit D on the keyboard for dimension, and then just click on that new line, and I'll give it a dimension. This is basically just a length. So I'll change it from whatever we had drawn before to 0.5. Now you can see that the only point that moved was this one, because these points are coincident, so it determined that this point has to stay fixed, and it can only move this side. Had we not fixed this curve down, it may have tried to move this point instead. So yeah, so that's why we did some of those things earlier. So now I'm going to adjust the angle of this. I'm going to create a line. Now this line is not really important. This is kind of more considered to be a construction line. This is going to be used as a horizontal reference to this, okay? And I know this is always going to remain horizontal because when I drew it, let's draw it again. I'll delete the line. When I hit L and then draw the line, you can see that yellow dotted line there. That means that it's always going to be relative to the horizontal axis, to the x-axis. So that's good. So now I can hit the D on the keyboard again for dimension and click on that line, and then I don't want to dimension the line. I don't care what the length of that line is. I just want to click again over top of this line, and now it'll let me select an angle. Okay. I'm not sure why I detected that's 147 degrees, but that's not what we want. Obviously, we want more like 26 degrees, okay, or 25 degrees, something like that. So I'm making these small changes to the difference between this line, which is fixed. This line cannot change its angle, and this line, which can change its angle. Okay. Yeah. Okay, so that's looking good. So now we're kind of done with the sketch for the moment, and then we'll come over here to 3D and we'll say revolve 2D sketch into a surface. And I'm going to do manual change. So I'm going to click on this curve followed by this line. And then you see we get our surface of revolution. Okay. So let's come back over here to the sketch real quick. You can see that looks kind of cool. You can kind of see the angle of the taper there and the 26 degrees. So we'll click on this and we'll just change that again a little bit. Change it to 30 degrees, right? And now we get, we're actually changing the 3D model. Change it to 25. Yeah. So if we don't want to extend out as long, we can change this to say 0.35. And now the whole thing will be a little bit shorter. Yep. Okay, so I hope that helps.